Okay, we're up and running. I got the recorder working. So welcome to our talk about the tangent line problem. So the big direction we're going to take today is, we've talked about if you have some kind of a function, and if you have a secant line connecting 2 points, and we might as well throw in a coordinate grid here while we're at it. I'll just do an axis and another axis. Okay, so we got a couple points here. And we can call this point here X. And we can call this difference here. And you can call this, I think our author calls it C. A lot of them call it X. It doesn't matter. It's a constant. Or it can be any value for X. It doesn't matter. Okay? That part doesn't matter. Use whatever you like. Anyway, and we call this delta X here. And then, well, or maybe I should go H. A lot of people call it H. Keep changing in my mind. We can call this X plus H. Should be black. We can call this X plus H and this X. So if this right here is X, what is this up here? F of X or F of C, whatever you used. Okay? And if this is X plus H, there you go. You're not missing a thing. This is F of X plus H. And that should start to look familiar because we've been dealing with it in the warm-up. Okay, so now riddle me this, Batman. If I have this triangle right here, this mean green thing, okay, if I have this triangle, then we always do rise over run. Thank you, Will. We always do, remember back in the day we did rise over run? And then later on we did y over x. And now we're doing delta y over delta x. And then this year shortly we're going to do derivative of y with respect to x, dy dx, what we call Leibnizian notation. Well, this is where we're headed. For right now, if you're trying to do the slope of this red secant line, what do I get? The slope of the secant line, well, what do you think? Yeah, using what we have. Well, what's the distance right here, from here to here? It would not. Ryan, throw out a lifeline? No, we're way past that. Those are the happy diaper days of slope. Yeah. Bailey, what do you think? It would, not or something like that. Own it, Bailey. It would be f of x plus h minus f of x. Okay? And that gives us a length. We cool with that? That gives us this length right here. Okay? Now, by the same token, let's do a Bailey on the horizontal change in x. What would this be? What would this be right here, this distance? Do a Bailey on that. X plus h minus x. Also known as AKA h. From there to there. Okay? Now, so then we could say the slope the slope of the secant line. God, this is fun. This is like the core of calculus. This is so fundamentally powerful. The slope of the secant line, we'll call that m sub secant or whatever, equals then what? We're doing rise over run, f of x plus h minus f of x all over. Skylar, were you on that? What's the next part, Skylar? Yes. The slope of the secant line. It's over h. It's over h. Now, we call the secant line then the average rate of change. Okay? Slope can be expressed as the average rate of change of the secant line come on. Man, this thing is evil and vile sometime. And then we'll say, get out of there. Still working out the bugs this year. Okay, all right, stay with it. Stay with it. Don't lose it, you guys. The average rate of change of the secant line over the interval from x to x plus h. Okay? Sweet. And that's just what you all told me, Forrest. Rate of change, rise over run, delta y over delta x, f of x plus h minus f of x divided by h. It's the same thing. It's the slope of that secant line. So, here we go. This is the cool part. This is when it goes from algebra to calculus. I mean, this is really algebra 1. But then we go to calculus. Now we say, what happens as h gets really, really, really small? In other words, if I take this secant line and I run it closer and closer and closer. See what's happening to h right now? Smaller and smaller and smaller. Now the average rate of change is getting closer and closer and closer to what we call an instantaneous rate of change. And if we let h approach 0, then we have no longer a secant line. We have a tangent line, right, Zach? And that, ladies and gentlemen, is the calculus. So let's write that then. Let's write this as the slope of the tangent line. What would that look like with our notation? You all know how to say it. You all know how to say it. How do we let that h go to 0? The limit. Oh, snappity snap. The limit as h approaches 0. Stay with it, everybody. The limit as h approaches 0 of f of x plus h minus f of x over h. Okay, and we're going to define this then as the derivative. Okay, and we're going to give it the kind of notation that looks like this. We're going to say the first derivative of f of x, which is, oh, come on, f prime of x equals It's not a 1. It's a, what do you call that? Apostrophe? Is that an apostrophe, a single one? Not like quotation marks, but a half a quotation mark, basically. Kind of like that, Bailey. So this is the definition of the derivative. Okay? This is our first day of calculus. This is fabulous. Now is a horrible time. Dude, this is where you're going to want to pay attention. Okay, now, this is fabulous and wonderful, and I'll tell you why. Because let's think of this in terms of, let me go for a new page. Let's think of this in terms of units, which we always should. Okay? So, Will, if you're doing something in physics, you have physics right now, Will? Okay, you took it last year. So in physics, you dealt with what kind of units all the time? Well, not that, or maybe I should say quantities. Like didn't you deal with, like, distance a lot? Okay. So we dealt with distance a lot. And what was the other big one you dealt with? In, not distance, but time. Good. Okay, that's what I was reaching for. So if you're dealing with distance in feet or meters, meters usually, and time in seconds, it's funny, you know, seconds was like a holdout that everybody's good with, you know. Everybody hates feet, and they should. But seconds they hung on to, which is pretty weird. Okay, so think about this. Think about this. So you'll have some kind of a function rocking and rolling out there in physics land. I don't know why that's not taking. Okay, you'll have some kind of function rocking and rolling out there in physics land, and if you have a secant line like we were talking about that's doing this, and you get the slope of the secant line, what units is that slope in? Or what would that be r? What units are that slope in? Yeah, exactly, because it's meters per second, which we know of it as is what? Velocity. We can say velocity with respect to time. Okay, so if you're dealing with a secant line, it's average velocity, right? It's average velocity, and if you do the first derivative, having issues, if you do the first derivative, then we can say, oh hey, this secant line gets, if I could grab it, gets closer and closer and closer to a tangent line, which might be like that, okay, at some point. So the average velocity of Orion becomes what? Well, in terms of a tangent line, that's fine. It's a tangent, but in terms of velocity, average becomes, well, how could we describe that? No. No. Okay, average velocity becomes, can you describe it, Orion? You know, as this becomes an average from one x value to another x value over that interval, that's called average. What would it be? And this is time, right? That's an interval of time. What would it be as we get velocity for one specific moment in time? Don't be shy. Instantaneous. Thank you, Orion. Instantaneous velocity. Okay, and I'm almost ready, you guys. I'm almost done. Hang in there. I have one little bit small thing to do, because this is major, this is important, and most days I will not talk this long, but oh my gosh, this is huge, okay? This is big, big stuff. Let's do one little problem that we know specifically, okay? So let's do a function like, I had a good one that's not in your book. I'll always try to do examples that aren't in your book. Okay, and we have time. Remember, we're on the activity schedule, so we have another how many minutes? Okay. All right, so let's do this. Let's say, and you're going to really want to pay attention. If you people have to go, then please watch the video. Okay? If f of x equal x cubed minus x. Okay? Now keep in mind our definition. Keep in mind f prime of x equals the limit, the first derivative, the instantaneous, as h approaches 0 of what? F of x plus h minus f of x over h. Okay, it doesn't look so bad, right? Well, we can say that that equals the limit as h approaches 0. And we love limits. I'm going to use a couple of different types of dividers here. Now we got to be careful. We had x cubed, right? So we have to, Mr. Man, so we have to say x plus h cubed. Then we had minus x, but we can't say x anymore. What do we have to say? X plus h. Okay, there's our first term. I know it is. I know it's confusing. You got to stay in there. It's supposed to be confusing. Ian. I'm not sure what your question is.
So if f of x equals x cubed minus x, why isn't that done x cubed minus x plus h?
Plus h. Oh, yeah, because whatever this x is, whatever is in that x term, that becomes x plus h. Okay? Yeah, you can't just tack it on. Algebraically, it doesn't work. Okay, all of this, right, is, I know you are. Bailey, you are confused. Okay? Now, you can say that 10 times. It's not going to help. But I will help you through it. This is hard. Okay? Now, they are. They are. Now we're going to go, we're almost done, hang on, minus, okay, we're almost there, f of x, what's that? There you go. X cubed, x cubed minus x, okay? And I know this is hard. You're not going to get it the first time, and that's fine. Over h. Okay? Now, what's the problem here? No, it's not ugly. It's lovely. And no, we can't go back to the first page because we're going to run out of time. We got to get through this. If you need to, watch the Vodcast tonight. Okay? The first page is there. Now, just like we did in the warm-up, we can process this. But again, what's the problem with h? It's all by its lonesome. That's not normally a problem. What else? Come on now, you can do it. No, what's the problem? You all know this. This isn't about simplifying. It can't equal 0, and we're trying to ask it to equal to 0. Thank you, Will. Okay? Can't equal 0. So your general goal in calculating these derivatives is to get this out of where? out of the denominator. Because, well, no. What does this represent, though? The change in x. So it has to be down there. Okay? No matter, and you can call it anything you want, it's going to be in the denominator. There lies the rub. Okay?
Can we just change all of that?
Yeah, you can try. All right, let's stay with it. Guys, girls. So we're going to, and again, you might not get this the first time, and that's okay. This is hard. So that's going to give us the limit as h approaches 0 of, we just did it in the warm-up, x cubed plus 3x squared h plus 3x h squared plus h cubed minus x minus h minus x cubed plus x.
Wait. Why did you give minus x?
Because this minus is going to distribute. Don't lose that. And that's a good question, Renee. A lot of people make that mistake. Remember, it's not the calculus that kills you. It's the algebra and arithmetic. Okay. It's not that bad. It's just long, Bailey. Stay with it. You can handle this. Okay. Equals the limit as h approaches 0 of, okay, 3x squared h plus 3x h squared plus h squared minus h. Okay? Well, what happened to h cubed? There's one there. There's a negative one right there. Okay?
But I think they're saying that the h should be cubed.
Oh, yeah. Right there. Thank you. Stay with it. Good. Okay? We've got a minus. Let's do different colors. We have a minus x here and a plus x here. We have a plus. See, it's not as bad as it looks. The future's getting brighter. We have a plus h cubed there and a minus h cubed there. It's not as bad as you think. Okay? And of course, before we forget, all of that over h.
No, where does the h squared minus h come from?
Where?
I'm,
Where?
because I don't see it up
The
there.
second h cubed is not an h cubed.
The second, this one right here?
The second one.
This one?
It's just
H
the second h cubed.
Right?
That's right. That one should not be h cubed.
Shouldn't that be? That's just an h?
Yeah.
Oh, bummer.
Yeah.
No, we were saying the one on the bottom should be h cubed, not h squared.
The one down here should be just h.
I mean, on the next step.
Okay, hang on. We got it. We're going to get it. It's okay. Just stay with it. Don't freak out. It's just because it's hard doesn't mean you can't handle it. Okay?
So now that that's cubed, it's
All right.
okay, so then the h squared needs to be h squared.
Okay, the h squared needs to be h cubed. Where are you at?
Yeah, go for it. She's told me so far. That one should be h cubed.
That one should be h cubed. Thank you.
What?
Oh, yes. I made a mistake. Thank you. That one should be h cubed. Now I think we're right.
Okay, yeah. Okay, I'm on board.
Okay, now I think we're good. Now, ladies and gentlemen, hang in there. We're almost there. So, Skylar, notice we have an h here, an h squared here, an h cubed here, and h here. So we can eliminate a ton of these, okay? We can divide everything then by an h term. So, which is really nice. But are we out in 23?
Yeah.
Okay, I guess we're going to have to finish this in the morning because I want you to get a good start tonight. Do your, or tomorrow afternoon rather, do your reading and notes on 2.1 if you haven't already. Okay? And Bailey, hang in there. It's going to be okay.
So
Yes, it is.
Are we going to finish this tomorrow in class, or will we find it online?
I'll finish it online because I'm really close. And then you can have it there as well. That's a good point. So I'll just pause it right now and do that.
No, I was into it. I was on
Okay, step next equals the limit as h approaches 0 of 3x squared plus 3xh plus h squared minus 1. Exactly, Skylar. And life is good. And that is the first derivative of x cubed minus x. And we designate that as f prime of x. Okay, so now let's let h go to 0. I'm going to move this out of the way. Now you'll notice nothing's in the denominator, so we can let h go to 0, and then this can become 3x squared plus 3x times 0 plus 0 squared minus 1. So f prime of x equals 3x squared minus 1. And there we are. We're done. And you'll find in the future that these are a lot easier than you think. But it is important to understand this basic definition. Outstanding. Thank you, and have a good day.